That would be 625. Yeah, third power equals 3. Okay. So log base 5 of 125 is equal to 3. Okay, we're all good with that so far, I think. Yeah, cool. And if we were to rewrite this in exponential form, this would be 5 cubed equals 125. Now, I'm going to show you something because right now we're in log base 5. However, we can convert this to log base 10 as long as we use the same base on both sides of the equation. This is an equation, yes? Everybody take a look. Everybody agree this is an equation? And in an equation, as long as you do the same thing to both sides, it's allowed. Everybody cool with that? Okay. So if I was just to write log of 5 cubed equals log of 125, would anybody have any arguments with that? Like, would you agree that log base 10 of 5 cubed is the same as log base 10 of 125? Makes sense, right? Because 5 cubed is 125. So applying log base 10 to both sides keeps both sides equivalent. Everybody okay with that? Okay. So we learned yesterday that if you have an exponent with a logarithm, how can we rewrite this? What's another way to write this, but without the exponent? Where can we move the exponent to get rid of it? Right here. Because we talked about adding logarithms yesterday is the same thing as increasing exponents. So we can rewrite this as 3 log 5. That's the same thing as log of 5 to the third power. You have 3 log base 10s of 5, which means you'd have a log base 10 of 5 multiplied by another log base 10 of 5 multiplied by another 10 of something equals 5. But you're multiplying factors of 10, essentially. And so you're increasing the exponents with those. And so this is the same as that. And so this is still going to be equal to log of 125 over here. Now, let's say, for example, that I want to make this equal to 3, just like this top one was equal to 3. How would I get 3 by itself here? Divide by what? By log 5, right? Yeah. So if we divide both sides by log 5 here, that means that 3 is not only equal to log base 5 of 125, it should be equal to log base 10 of 125 divided by log base 10 of 5. Those two things should be equivalent, according to the math that we just did. Let's verify. So first thing, let's just go back and do the normal. Let's go to our log base. So click on math, scroll up a couple times, get to log base. Type in log base 5 of 125, and we should get an answer of 3, and we do. Because we knew that was going to be true. 5 cubed is 125. So let's also, once we have that, type that in. Once we have that, let's go to the bottom here and type this in without using log base, just using regular log. So open up a fraction, go to math, scroll over to fraction, type in just log, not log base this time, just log of 125 over log of 5. What do you get? 3, same thing. So what we're saying here is if you're in a situation where you can't use log base on a calculator, because some calculators don't do log bases other than 10, there is a change of base formula that we can use to change things from base whatever to base 10 and still get the same answer. This was base 5 to begin with. Now it's base 10 here, but we still get the same answer because we did a little bit of algebra and what we did worked and it was allowed. And so we just kept it and went with that answer. So let's try try with this one. So if we're going to do this, it says to evaluate the calculator, you need to express it in terms of base 10 logarithms. Not true with this calculator, but with a lot of calculators, it is true. So let's just write log base 2 of 3 is equal to, let's just call it x. Log base 2 of 3 equals x. So we're going to do the same thing on this problem that we did on the last one. We're going to use algebra again. Then I'm going to ask if you notice any patterns based on our first example here and this one that we're doing right now. So first of all, we don't know what x equals, but we can write it in exponential form, and we could say 2 to the x equals 3. That's what it looks like in exponential form. So if you follow along with what we're doing here, we're doing the same thing that we did on this side here. So once we wrote in exponential form, we then added log base 10 to both of these expressions here. So we're going to write log of 2 to the x equals log 3. Then we're going to use the power rule with logarithms, move our x in front of the log. So we're going to have x log 2 equals log 3. So that means that if we go back up here, x is going to equal, we have to divide by log 2 on both sides. X is going to equal log 2 divided by, log 3 divided by log 2. So we're dividing by log 2 on both sides. So we're changing the base from a base 2 to a base 10. And if we type both of these things into our calculators, they should give us the same answer. So let's see what happens then. So I'm just going to copy and paste my original one, log base 5. I'm going to scroll back, change the 5 to a 2, delete a couple of these numbers, change the 5 to a 3. And so we're looking at 1.585 if you want to expand that a little bit further. So then if we go ahead and we type in log 3 divided by log 2, that should give us the same as log base 2 of 3. So open up a fraction, log 3, divide by log 2, and what do you know? Exact same thing. So x is approximately 1.585. Are there any questions about this process? Because I'm about to show you a shortcut. Even though this doesn't take all that long, there is a shortcut to it. But I want to see if we can figure that out before we go to the next page. So take a look here. What do you notice about the numbers that are being divided versus the original equation? And what do you notice here about the original equation and the numbers over here that are being divided? What's that? So the original base is now log base 10 of 2 on the denominator. What about the numerator? Yeah, so the argument, so the log of the argument is on the numerator, and then the original base value with log is on the denominator. That happened over here as well. The argument was 125, the original base value is 5. The original argument was 3, the original base value is 2. So there's a law that says we can go straight from here to here, because that pattern will always hold. So if you turn the page, the change of base formula says for positive numbers, M, B, and A, with B not equal to 1, because the base 1 doesn't really do much. And A also does not equal 1, because that's another base value over here. Now the change of base formula, we are using the change of base formula to change it to base 10. But it can be used for other things as well. But we're focusing on base 10 right now. So whatever your original base value and your argument are, turn into log base of whatever the new base is, which for us will be 10. A will be 10, which means we don't have to write it, of the original argument, and then log base of the new 110 of the original base value. So Here's a couple examples here. This one right here, our original argument is 7, our original base value is 2. So we're going to estimate the value of each logarithm and then use a calculator to find the value to the nearest 1,000. So basically we're saying 2 to what power is equal to 7? What do you think the answer should be without using a calculator at first? 2 to what power equals 7? 1.5-ish? Okay. What's that? 2 point something? Okay. I would lean towards Tyson's answer there because 2 squared is 4 and 2 cubed is 8. So it's going to be somewhere in between 2 and 3. So yeah, 2 point something, right? In between 2 and 3. So let's write this as a division of log base 10. So what's it going to look like? Let's say x equals, how do we write this as division of log base 10? What are we going to write? Yeah, log 7 divided by log 2. That's it. So type that in. We should have an answer somewhere in between 2 and 3. And 2.807. So closer to 3 than 2. To the nearest 1,000, 3 decimal places, there it is. So we use the change of base formula. So this is going to be mostly useful if you're using a calculator that doesn't do a base other than 10. Or unless, of course, the problem tells you to rewrite it using the change of base formula. In that case, you would need to do that. So try B on your own, see what you get. Any guesses as to what the number might be? Did you already solve it? Okay. I was thinking it'd be probably right around 1/2-ish. That would be my initial estimation, is that it's going to be somewhere in between 0 and 1, but it'll be positive for the exponent. But probably closer to 1 than 0. So between 1/2 and 1 would be my guess. So what does this look like as division using base 10? What are we going to write? Yeah, log 3 divided by log 5. And what does it end up being? 683? Okay. So x is about 0.683. Cool. All right. So there's that. There's every tiny little individual thing we do, as is the case with a lot of math, is that every little tiny thing we do isn't all that complicated, but then once you introduce it into a problem where you have to do a bunch of them in the same problem, that's when things start to get a little bit more challenging, because you're like, what do I do first? Do I have to use this property here or not? And then so that's when the questions usually arise. And so if you end up with questions, ask them. But let's go ahead and work on this very last example, and then we'll have the remainder of class to get working on the assignment. So what is the solution for the equation 2 to the x equals 7? Express the solution as a logarithm and then evaluate and then round to the nearest 1,000. So as a logarithm, what does this look like? Okay. Log base 2 of 7 equals x. And it says, use the change of base formula. Didn't we? We already did this one, didn't we? What's that? Yeah, that was. When did we do this one? Oh, it's A, the one up top. Weird. Anyway, so it's the same problem. We already did this one. Log 7 divided by log 2, so x is approximately 2.807. Cool. I'm not even, well, I'll write the, yeah, log 7 divided by log 2. We'll write out the division using log base 10. Okay. The next one, though, we have not done yet. We haven't done the next problem, so I want you to give that one a try. It should be somewhere, X should be somewhere in between 2 and 3, but probably a lot closer to 2 than 3 would be my guess. Once you solve for X. Use the change of base formula though, because it tells you to. So take a minute on that. Work through every part of it, and then we'll see what we get. So is X between 2 and 3, but closer to 2 than 3? 2.465? All right. So hopefully we wrote log base 3 of 15 equals X. And then hopefully we wrote X equals log 15 divided by log 3. And then hopefully we wrote the answer of about 2.465. So all three of those things need to be part of the answer or part of this problem. So if this is a test question, all three of those things would need to be present if it said to use the change of base formula. Convert to logarithm, write it as division in base 10, and then write your answer after that. All right. So that's it for this lesson. We've got until 1:40, so we have a half hour to continue working.